Good morning everyone. Welcome to Narayana online classes. Today for 8th class we are going to deal with trigonometric ratios and their relation and Pythagoras theorem. So we see what are the different trigonometric ratios we have and what is the relation. Then we talk about Pythagoras theorem. Then we do certain problems based on this particular sequence. Fine. If you take a unit circle is the one whose radius is 1 unit. It can be 1 meter or 1 centimeter or it can be any 1 unit what we want to say. Fine. If it is the center of the circle, it is a radius. Let me take like this. Now it is a point P, or let us take it as some point A, OA. Now let us see that there is the point is traveling certain distance by describing an angle theta, and the final position of the point is P. Okay. Now let us take P has its x and y coordinates as x and y, Pxy. Now let me draw a perpendicular on this OA. Now this is the horizontal component and it is a perpendicular component, as O stands for the origin. Okay. Now this particular length and this particular length, let us take. This is the length O to this particular point, let us call it as M. O to M is what we call as X, and P to M we call it as Y. And theta is the angle described by OP with OA. Now, as per the definition of sine theta, that is the first trigonometric ratio, sine theta is given as opposite side to theta, that is Pm upon OP, nothing but the radius of the circle. So Pm by OP, that is otherwise y upon r. Then cos theta is defined as this adjacent side for this theta. Okay, so that is OM upon OP, that is otherwise x by r. Okay, next we have tan theta. Tan theta is defined as opposite side to theta by adjacent side to theta, that is Pm upon OM, that's equal to y upon x. Next we have cosecant theta. Cosecant theta is defined as OP, that is the hypotenuse, upon opposite side, that is Pm, that is r upon y. Next we have secant theta. Secant theta is defined as OP, that is the hypotenuse, upon the adjacent, that is OM, that is equal to r upon x. Next we have the cot theta, cotangent theta, that is simply called as cot theta. Cot theta is defined as, that is adjacent side to theta upon opposite side, that is OM upon Pm, that is equal to x upon y. So this is basically the basic definitions of sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. Okay, now let us see the relation between them. The relation between them is, first one, if you take cosecant theta, that is 1 upon sine. Cosecant theta is 1 upon sine theta. So these two are said to be the reciprocal ratios. If you find out the product of these two, that results in 1. Okay, that implies sine theta into cosecant theta, that's equal to 1. Next, the second one is secant theta is equal to 1 upon cos theta, that implies cosecant cos theta into secant theta is equal to 1. Third one is tan theta is equal to 1 by cot theta, or cot theta is 1 by tan theta. You can write it anyway. Cot theta is 1 by tan theta. That implies tan theta into cot theta is always equal to 1. Okay, next we have tan theta as sin theta upon cos theta. all we can obtain by using earlier definitions. Fine. Now, what is Pythagoras theorem? Suppose in a right angle triangle ABC, suppose we have a triangle ABC which is right angle at B. So ABC is right angle triangle at B. According to the Pythagoras theorem, square of the hypotenuse. What is hypotenuse? The side opposite to the right angle is said to be the hypotenuse. So square of the hypotenuse is equal to sum of the squares of other two sides. So what are the other two sides? AB and BC. So AC square is equal to AB square plus BC square. This particular statement we use as a theorem, and that is named as Pythagoras theorem. He is a mathematician who introduced this into the mathematics. Fine. So now, based on these concepts, whatever we have seen right now, we are going to do few problems. Fine. Let us start. The first problem is, if 3 cot A is equal to 4, if 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Here what is saying? We are given 3 cot A is 4. Based on this particular relation, we are asked to check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Fine. Let us see. Solution, let us start. What is given? We are given 3 cot A is equal to 4. That is otherwise, cot A is equal to 4 upon 3. Okay. If you draw a right triangle, let us take this as A, because we are saying cot A is as 4 by 3. So better to take angle A over here, and this is BC. Let us consider that at angle B we have the right angle. So angle B is 90 degrees. Now, as cot A is 4 by 3, according to the definition of cot A is defined as adjacent side to A, angle A, by opposite side to angle A. That is the definition of cot A. Otherwise, we say that it is base upon perpendicular. One more way of defining cot A is base upon perpendicular. So base is AB here, perpendicular is BC here. So cot A stands for BA by or AB by, we have BC. That is equal to 4 upon 3. Therefore, we can say AB is equal to some 4K and BC is equal to some 3K. As they are in a ratio, we better take AB as 4 times of some real value and BC as some 3 times of some real value. BC is equal to 3K. Now we want AC, because if you want to define tan, cos or sin, for tan it is okay with these two, but cos A and sin if you want to define, you need to know the value of the hypotenuse, that is AC. So first thing is that you have to find out the value of AC. So for that, you know AB as well as BC, then how can you find out AC? Then we have to go for Pythagoras theorem. Pythagoras theorem is helping us in finding out AC value if you know AB and BC. Therefore, by in triangle ABC, let me write this. In triangle ABC, angle B is equal to 90 degrees. Okay, therefore, we will start here. By Pythagoras theorem, we have AC square is equal to AB square plus BC square. Okay, that is otherwise AB. AB is given as 4K, that is 16K square plus BC, that is 3K. So that is 9K square. Let us simplify that. If you simplify that, that is going to be 25K square. as it is 25k square, AC square is 25k square, AC we have 5k. AC value is 5k. Now we know BC, AB as well as AC. Now it is easy for us to define cos as well as sin. Let us do that. So here we have AB as 4k, BC as 3k. Okay, now what we are going to see, AC already we have this as 5k. Now we are going to see what is tan A. Let us see. Let us take tan A. Tan A is equal to, we know that according to the definition of tan A, it is opposite side to A by adjacent side to A. Otherwise we can say it is a ratio to perpendicular to base. So that is BC by AB, that is 3k upon 4k, that is simply 3 upon 4. Now we will define in sin A. Sin A is equal to, according to the definition of sin A, it is opposite side to A by hypotenuse, or we can say it is the ratio to perpendicular to hypotenuse. So we can say it as BC by AC, that is 3k upon 5k, that is equal to 3 upon 5. Next, cos A. Cos A is defined as adjacent side to A, angle A by hypotenuse. Otherwise, it is a ratio to base to hypotenuse. So we can say it as AB by AC, that is 4k upon 5k, that is 4 by 5. So these are the values we have. Using this, we can prove whatever he is asking us. Whether it is correct or not, we have to check. Now, let us go further. One minus tan square A, LHS part, by 1 plus tan square A. That is the LHS part of the given. 1 minus tan square A by 1 plus tan square A. That is 1 minus tan A is 3 by 4. So it is 3 by 4 whole square upon 1 plus 3 by 4 whole square. That is going to be 1 minus 9 upon 16 by 1 plus 9 upon 16. Okay, that is going to be 16 minus 9, that is 7 upon, this is 16 plus 9, that is 25. 7 upon 25. Next, we will see RHS part, cos square A minus sin square A. Cos square A, we have cos A as 4 upon 5, that is 4 upon 5 whole square, minus sin A as 3 upon 5. So 3 upon 5 whole square, that is 16 upon 25 minus 9 upon 25. So as they are like fractions, 16 minus 9 is 7 upon 25. So if you look at the results, both are equivalent to 7 upon 25. Therefore, we can conclude 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. In later classes, we will come to know that it is a formula, that is cos 2A. In multiple submultiple angles of trigonometry, we will study it as a, we will learn it as a formula for cos 2A. So 1 minus tan square A, 1 plus tan square A is cos square A by cos square A. Without using that particular, saying it as a formula, we are proving using the triangle, the sides of the triangle. Basic trigonometric ratios. Fine? Good. Now, let us move to the next question. The next question is, if 4 tan theta is equal to 3, find the value of 4 sin theta minus cos theta upon 4 sin theta plus cos theta. This is the problem we are asked to do. Fine. Solution, let us start. What is given for us? We are given the 4 tan theta is equal to 3. 4 tan theta is 3 degrees, otherwise tan theta is 3 upon 4. Okay, now let us just take a right triangle, right angle at some B. Here no restriction whether to take A here or here because it is only theta, so I can specify it as theta. Okay, now tan theta is 3 by 4. According to the definition of tan theta, we know that it is the ratio to perpendicular to base or opposite side to theta by adjacent side to theta. So we can say it is AB by BC, that is equal to 3 by 4. Therefore we can say AB is equal to some 3k, BC is equal to some 4k. Again the same thing here, we need to know the value of AC as we have to find out the values of cos theta and sin theta. So AC is mandatory. So we have to go for Pythagoras theorem again. By Pythagoras theorem, we have AC square is equal to AB square plus BC square. That is going to be AB square is 3k to 9k square plus 16k square. That is 25k square. So we have the result as 25k square. Therefore, AC square is equal to AC we take. AC square is 25k square. AC is equal to 5k. So we got the value of hypotenuse as 5k. BC is already 4k and AB is 3k. So based on this, we have to find the value of 4 sin theta minus cos theta by 4 sin theta plus cos theta. Let us find its value. Now we have 4 sin theta minus cos theta by 4 sin theta plus cos theta. That is equal to 4 into sin theta. Sin theta is, what is sin theta here? Sin theta is defined as opposite side to theta by hypotenuse, or we can say it is a ratio to perpendicular to hypotenuse. So perpendicular is here 3k by, or this is AC, or let us do one thing, fine. AC is 5k minus cos theta. Cos theta is defined as adjacent side to theta by hypotenuse, or we can say it is a ratio to base and hypotenuse. So that is 4k by similarly 4 into here also sin theta 3k by 5k plus cos theta, that is 4k by 5. That is otherwise k cancels throughout. So what we have, 4 into 3, that is 12 upon 5 minus 4 upon 5 by 12 upon 5 plus 4 upon 5. That is going to be, as these two are like fractions, 12 minus 4 is 8 by 5 divided by, here is a 12 plus 4, that is 16 upon 5. So 5 cancels, so we have 8 upon 16, that is 1 upon 2. So the resultant answer for 4 sin theta minus cos theta by 4 sin theta plus cos theta is 1 upon 2. This is what we can say. Fine. Let us move to the next question. If sin theta is equal to 12 by 13, then find the value of secant theta plus tan theta by secant theta minus tan. It is almost similar question. What is given for us? Given is sin theta is 12 upon 13. We are given that sin theta is 12 upon 13. Now let us take the triangle. If it is theta, no restriction to take A, B, C, we can take them anywhere. Let us take angle B, at angle B have 90 degrees. So as it is sin theta, according to the definition of sin theta, it is opposite side to theta by hypotenuse, or it is a ratio to the perpendicular to hypotenuse. So it is some 12k and 13k. So we have sin theta is AB upon AC, that is 12 upon 13. Therefore we can say AB is equal to 12k, AC is equal to 13. Again we need BC. Why we need BC? To define tan theta or secant theta, we need BC. How can you get BC? Again we have to make use of Pythagoras theorem. Therefore, by Pythagoras theorem, what is that? AC square is equal to AB square plus BC square. That implies AC square is, that is 169k square, is equal to AB square, that is 144k square plus BC square. Okay, if that is simplified, BC square we are going to have 169 minus 14k square if we transpose it to this side. So that is going to be 25k square. It implies BC is going to be 5k. So the BC value we have as 5. Now we have three sides, like AB value we have, BC we have, and hypotenuse also we have. So based on these three, we can define any trigonometric ratio. Now let us find out the required result. Now, he is asking us to find out secant theta plus tan theta by secant theta minus tan. So that is equal. What is secant theta? Secant theta is defined as hypotenuse by base. Base or adjacent side to theta. So that is 13k upon 5k plus tan theta. Tan theta is defined as opposite side to theta by adjacent side to theta or perpendicular by base. So that is 12k by 5k upon, same, here also the same thing, so 13k by 5k minus 12k by 5. If you simplify further, these two are like fractions, k cancels through, 13 plus 12, that is 25 by 5 divided by, this is 1 by 5, so that is going to be 25. So the value of secant theta plus tan theta by secant theta minus tan theta is going to be 25. Okay, let us move to the next more problem. In triangle PQR, the problem is like this. Right angle at Q, angle Q is equal to 90 degrees. PR plus QR is 25 centimeters. PR plus QR is 25 centimeters. And PQ is 5 centimeters. Determine the values of sin P, cos P and tan P. Then find sin P, cos P, tan P. So these are the principles. If you read the question, in triangle PQ, angle P is 90. He is saying that the triangle is a right triangle.